Question 6. What is the volume of this rectangular prism in cubic centimeters? Now, since the answer is in cubic centimeters, the dimensions need to be in centimeters. So the first thing I did was to convert the 4 meters and the 0.05 meters into centimeters. So multiplying both of these numbers by 100, we have 4 meters is equal to 400 centimeters, and 0.05 meters is equal to 5 centimeters. Next, we just multiply those three dimensions together. So 30 centimeters multiplied by 400 centimeters multiplied by 5 centimeters, and we get 60,000 cubic centimeters. So it's option C. Question 25. The solid shown is made of a cylinder with a hemisphere, half a sphere, on top. What is the total surface area of the solid to the nearest square centimeter? Now we can break this shape up into 3 parts. So we have the hemisphere, we have the curved surface of the cylinder, and then we have the flat surface at the bottom in the shape of a circle. So we can work those out separately, add them together, and that'll give us the total surface area of the solid. So firstly, let's determine the radius. So that's half the diameter. Diameter is 8 centimeters, radius is 4 centimeters. Next, let's work out the surface area of the hemisphere. And the formula for the surface area of a hemisphere, we take a sphere, so that's 4 pi r squared, and then divide that by 2 to get half a sphere, or the surface area of half a sphere. So the hemisphere is 4 times pi times r squared, 4 squared, and then we divide that by 2, and that equals 100.53 square centimeters. Next, we'll work out the curved surface of the cylinder. So it's like there's a label around it. Imagine there's a label, you unwrap the label, and you want the surface area of the label that wraps around. And that's found by the formula 2 pi r multiplied by h, the height of the cylinder. So 2 times pi times the radius times the height of the cylinder, 21 centimeters, and that equals 527.79 square centimeters. So I've rounded these subtotals to 2 decimal places because the total just needs to be rounded to the nearest square centimeter. And finally, the base, which is a circle, and that's found by the formula pi r squared. So pi times 4 squared is equal to 50.27. Now adding this and this and this, so these 3 values, combining those together, we get 678.59 square centimeters. So rounding that to the nearest square centimeter, it's 679 square centimeters. So the answer is option B. Question 27b. The sector shown has a radius of 13 centimeters and an angle of 230 degrees. What is the perimeter of the sector to the nearest centimeter? So the perimeter is the arc length plus the 2 radii. So the arc length is found by applying the formula 2 pi r multiplied by theta over 360. So that's the fraction of the circumference that corresponds to the arc length that we want. And that's equal to 2 times pi times 13 times 230 over 360. And that equals 52.185 ... So it's a whole decimal there, I only wrote the first 3 decimal places. And that's the arc length. So to get the perimeter, we take the arc length that we just found and we add on the 2 radii. So plus 13 plus 13, so don't forget to add this side there as well. And that equals 78.185 ... centimeters, but rounding that to the nearest centimeter, that equals 78 centimeters. Question 12. A square pyramid fits exactly on top of a cube to form a solid. What is the volume of the solid? We can see that it's a composite shape, so we have a cube and a pyramid. Now the volume of the cube is easy enough, so it's 9 times 9 times 9, 9 cubed. However, the volume of the pyramid requires a little bit of extra work. We need the area of the base, and we need the height of the pyramid to be able to work out its volume. So the area of the base is 9 centimeters by 9 centimeters, which is 81 square centimeters. The next thing we need is the height of the pyramid, which is 19 centimeters minus the height of the cube, which is 9 centimeters. And that gives us 10 centimeters. Finally, we can work out the volume of this composite shape. So volume is equal to 9 cubed, so that's the volume of the cube, plus 1/3 multiplied by the area of the base multiplied by the height of the pyramid. And that gives us 999 cubic centimeters. So option B. Question 16. The shaded region shows a quadrant with a rectangle removed. What is the area of the shaded region to the nearest square centimeter? Now recall that a quadrant is 1/4 of a circle, and the area of a circle is pi r squared. So the area of a quadrant is 1/4 multiplied by pi r squared. But before we consider the area of the quadrant, we need the radius of this quadrant. And the radius of the quadrant is 3 plus 6, which is 9 centimeters. Now, to work out the area of this composite shape, we work out the area of the quadrant, and then we take away from that the area of the missing rectangle. So area is 1/4 multiplied by pi r squared, so pi multiplied by 9 squared, minus the area of the rectangle that's been removed, which is 6 multiplied by 2. And we get 51.617, dot, dot, dot. And to the nearest square centimeter, that's 52 square centimeters. So it's option B. Question 19. A logo is designed using half an annulus. What is the area of the logo to the nearest square centimeter? And we can see here that we have a large semicircle, and from that we're going to take away a smaller semicircle. So we'll need the radius for both the large semicircle and the radius for the smaller semicircle. So let's work that out first. Now the radius of the large semicircle is 5. Diameter is 10, half of that is 5. So that's how we work out the radius. Of course, it's half the diameter. Next, we'll need the radius of the smaller semicircle. So it's going to be 10 minus 3 minus 3. So 10 minus 3 minus 3 is 4. That's the diameter of the smaller semicircle. Half of that is 2. Next, we can work out the area of this particular composite shape. And that'll be pi times r squared. So this is the large r, 5 squared, so the large semicircle. I'm treating it as a circle at first. I'll be dividing by 2 at the end because we are dealing with semicircles. So let's work it out as if it was a whole circle. So pi r squared, pi times 5 squared, minus pi times 2 squared. So this is the small r, the smaller radius. And of course we need to divide that by 2 because we are dealing with semicircles. And that gives us 32.986 dot dot dot. And of course that rounds to 33 square centimeters, correct to the nearest square centimeter. So option B. Question 25. A net is made using 4 rectangles and 2 trapeziums. It is folded to form a solid. What is the volume of the solid in cubic centimeters? Now the first thing to note that if this solid was folded up, it would actually form a prism. And it'll form a prism where the cross section is a trapezium. So think of the cross section like you're going through a tunnel, and around you it's exactly the same shape as you walk through the tunnel from one end to the other. So in this case, the tunnel is a trapezium shaped tunnel from one end to the other. So to find the volume then of this shape, we need to find the area of the cross section, which is the trapezium, and then we multiply that by the depth of the tunnel or the height of the prism, whichever way you want to look at it. So the area of the trapezium cross section, so let's move the page up a little bit, is half multiplied by the distance between the parallel sides, which is 8 centimeters, multiplied by 11 plus 5. So that's the sort of the bottom side of the trapezium plus the top side of the trapezium. In fact, if I turned the shape this way, you can see the trapezium a lot easier this way. So there's the height of the trapezium, 8 centimeters. The top of the trapezium is 5 centimeters, so that comes from this edge here. So 5 and 5 there. So when they fold up, they meet, of course. And this side here would be 11 centimeters. And that equals 64. And to find the volume, we take the area that we just found, which is 64, multiplying it by the height or the depth of the prism, which is 9 centimeters. And we get 576 cubic centimeters. So it's option D. Question 27D. A rectangular wooden chopping board is advertised as being 17 centimeters by 25 centimeters, with each side measured to the nearest centimeter. Part 1. calculate the percentage error in the measurement of the longer side. Now the first thing we need is the precision or the accuracy of the measurement, and that's given in the question. So these measurements are measured accurate to the nearest centimetre. So the smallest unit of measure, or the precision, or the accuracy is 1 centimetre. Now the next thing we need is the absolute error, and that's worked out by taking the precision and dividing it by 2 or multiplying it by half. So the absolute error is equal to half multiplied by the precision, which is 1 centimetre, and that's equal to half a centimetre or 0.5 centimetres in decimal. Finally, we can work out the percentage error. And we work that out by taking the absolute error, dividing it by the measurement in question, which is the measurement of the longer side, which is 25 centimetres, and then multiplying the result of this fraction by 100, and don't forget to add the percentage symbol at the end. And the answer is 2%. So for part 2, between what lower and upper limits does the actual area of the top of the chopping board lie? And to work that out, we need to know or work out the lower and upper limits of both the width and the length. And to work that out, we need to apply the absolute error. So the advertised length is 25 centimetres, but the absolute error is 0.5 centimetres. So what this means is that the actual length, or the length in reality, varies between 24.5 centimetres right up to 25.5 centimetres. Now for the same reason, the width also varies based on the absolute error. So if the advertised width is 17 centimetres, the absolute error is 0.5 centimetres, so that means that the width in reality could be from 16.5 centimetres right through to 17.5 centimetres. So to work out the minimum area, or the lower limit of the area, you multiply the lower limits of both the length and the width. And the result is 404.25 square centimetres. And to work out the maximum area, or the upper limit, multiply the upper limits of both the length and the width. So 25.5 multiplied by 17.5, and the maximum area, or the upper limit for the area, is 446.25 square centimetres. Question 2. A measurement of 72 centimetres is increased by 20%, and then the result is decreased by 20%. What is the new measurement correct to the nearest centimetre? So starting off with 72 centimetres, increasing that by 20%, we multiply by 120%, and then decreasing that by 20%, we multiply it by 80%. So 100 minus 20%, which is 80%. To give us a total of 69.12 centimetres, and correct to the nearest centimetre, that'll be option B. Question 10. The top of the Sydney Harbour Bridge is measured to be 138.4 metres above sea level. What is the percentage error in this measurement? Now there's 3 things we need to consider. The first is the precision or the accuracy of the measurement. So we can see here that it's measured accurate to 1 decimal place, or 0.1 metres. The next thing we need to work out is the absolute error, and that is half times the precision, or half times 0.1 metres, which is 0.05 metres. And finally, the percentage error is worked out by taking the absolute error, dividing it by the measurement itself, which is 138.4 metres, multiplying it by 100, and the result is 0.036%. So answer is A. Question 12. A path 1.5 metres wide surrounds a circular lawn of radius 3 metres. What is the approximate area of the path? Now this can be found by finding the area of the outer circle and subtract from that the area of the inner circle. So it's the area of a composite shape. Now the radius of the outer circle is 3 metres plus the width of the path, so that gives us a radius of 4.5 metres. And of course the radius of the inner circle is 3 metres. So area of the outer circle minus the area of the inner circle, and that's it there on a calculator. Press equals and you'll get 35.3429, and that rounds to 35.3, option C. Question 25. A grain silo is made up of a cylinder with a hemisphere, half a sphere on top. The outside of the silo is to be painted. What is the area to be painted? Now the first thing to note is the diameter of the silo is 48 meters and the height of the cylindrical part of the silo is 30 meters. So the first thing we'll work out is the radius, and the radius is half the diameter, so the radius R is 24 meters. The next thing we'll work out is the surface area of the silo wall, so just the curved surface of the cylinder, and that's 2 pi times R times H, for the height of the cylinder, and that gives us 4,523.89 square meters. The next thing we'll work out is the surface area of the hemisphere. And we'll do that by working out the surface area of a sphere and then dividing it by 2. So the surface area of a sphere is 4 pi r squared, but we'll divide that by 2 to get the half sphere, or the surface area of the half sphere. And that's 3,619.11. Now the total surface area is 4523.89 plus 3619.11, and that gives us 8,143 square meters, and that's option A. Question 27C. The base of a water tank is in the shape of a rectangle with a semicircle at each end as shown. The tank is 1,400 millimeters long, 560 millimeters wide, and has a height of 810 millimeters. What is the capacity of the tank to the nearest litre? So I'm going to treat this as a volume of a prism type question, even though technically speaking it's not a prism because of the cylindrical components of this shape. We can still treat it as a prism. So volume equals area of the base, or is the base of the tank there, multiplied by the height of the tank. And of course we'll need to convert that into a unit of capacity, and we're asked to convert it to litres, correct to the nearest litre. Now to make that a little bit easier, I'm going to convert all measurements to centimetres, because converting cubic centimetres to litres is quite straightforward. The other thing I need to consider is the radius of the semicircle. So let's look at the base of the tank. We need the area of the base. We can see that it's composed of 2 semicircles. So 2 semicircles brought together makes a full circle, of course, so we can just consider a full circle. And we have a rectangle in between the 2 semicircles. So the area of the base is pi times 28 squared, because the radius of the semicircle is 28 centimeters. So 56 centimeters is the diameter. That's how I got the 28. So area of the base is pi times 28 squared plus 140 minus 56. So that's the length of the rectangular part. So that's 28 centimeters there. That's 28 centimeters there. Of course, that's the radius of the 2 semicircles. And the length of the rectangle is 140 minus 56, and then multiplied by the width of the rectangle. That's 56 centimeters there. So I'll put that all in one calculation, and that results in 7,167.00864 square centimeters. Notice that I didn't round it there. I'm going to round at the very end. Now the next thing is to find the volume of the tank. So we take the area of the base that we just found, and we multiply it by the height of the tank. So volume equals A times H. And I multiply it by 81, and that gives us 580,527.6999 cubic centimeters. Now cubic centimeters is equivalent to milliliters. So in fact, I could just cross out the cm3 or the cm cubed and write ml in its place, since 1 cubic centimeter equals 1 milliliter. So to convert that then into litres, or the unit of capacity here in litres, we're going to divide this figure by 1,000, and that gives us 581 litres, correct to the nearest litre. Question 1. What is 1,560,200 kilometres written in scientific notation correct to 2 significant figures? So I'm going to answer this question 2 different ways. The first way, the manual way, is to locate the most significant figure, which is the figure on the left-hand side here. So starting with the 1, this is the most important placeholder, the most important digit, because it represents 1 million. The next most important significant figure is the 5. So this represents the hundreds, the 100,000 place, or the hundreds of thousands. And the other digits are not significant. Now, the 6 here will cause the 5, this digit 5, to be rounded up to a 6. and the remaining digits then from the 60200 will just become all zeros. So this becomes the number 1,600,000. And that makes sense since this number is pretty close to 1,600,000. Now the next step is we need to then express this in scientific notation. So starting off with the decimal point there on the right hand side, let's count how many decimal places we need to move it to get it between the 1 and the 6. So that's how we express a number in scientific notation. 1, 2, 3, 4, 5. There's 6 places there. Okay, so this will be 1.6. then multiplied by 10 to the power of 6. So it's going to be option D. Now, the other way to round a number and express a number in scientific notation at the same time is a nice option or mode on your calculator. Now, let me just brighten the camera a little bit there. Shift mode, and it sort of gives you a sort of a set of options there. Option 7, SCI. So that means scientific notation, but it also rounds to a certain number of significant figures. So select that. It'll then ask you for the number of significant figures. So press 2. Okay, and then we'll just type in this number, this ordinary number, 1,560,200. Now, if you press equals, it will round the number for you and write it in scientific notation or express it in scientific notation at the same time. So again, that confirms option D. Question 8. The Louvre Pyramid in Paris has a square base with side length 35 meters and a perpendicular height of 22 meters. What is the volume of this pyramid to the nearest cubic meter? So first of all, we know it's a pyramid. Okay, we're told that. And the formula for the volume of any pyramid is V equals 1/3 multiplied by the area of the base multiplied by the height. Now, this is a square-based pyramid. Okay, we're sort of told that in the question, so you can underline that if you like. So we could just apply or substitute in the numbers or the values into the formula. So we have 1/3 multiplied by A, which is the area of the base. Now, it's a square, so the area of a square is 35 multiplied by 35. And then we're going to multiply it by the perpendicular height, which is 22 meters. And multiplying all that together. Okay, so we have 1/3 multiplied by 35 multiplied by 35, or 35 squared, of course, whichever's quicker. And press the SD button, we get 8983. So as to the nearest cubic meter. 8983 cubic meters. So that's option C. Question 12. The length of a fish was measured to be 49 centimeters, correct to the nearest centimeter. What is the percentage error in this measurement, correct to one significant figure? The first thing we need to do is to find the precision. How precise is this measuring instrument? And that is given by the smallest unit it can measure. It looks like it measures in lots of, well, in centimeters or in whole centimeters. So that would be as precise as this instrument can get. So it measures correct to the nearest centimeter. So that's its precision. Now the next thing we need is its absolute error, which is half the precision. So that's going to be 0.5 centimeters. Now the next thing we need is now the percentage error. We'll calculate that. So we take the absolute error. So this is the percentage error now, is equal to the absolute error, 0.5, over the measurement itself, which is 49 centimeters, and we multiply that by 100, of course, because it's a percentage. Okay, so let's enter that in now. 0.5 over 49 multiplied by 100, and we have 1.020, so it's 1.020 ... and that's a percent or percentage. So correct to one significant figure, it's 1%. So it's going to be option C. Question 26F. Approximately 71% of Earth's surface is covered by water. Assume Earth is a sphere, and also assume that the radius of the Earth is 6,400 kilometers. So this is a question again from an older syllabus where the radius of the Earth is in fact stated in a formula sheet. We don't state that or even use that in a formula sheet in the current syllabus. Generally, something like this is normally given or may be given in a question. So I'm going to give it here. Calculate the number of square kilometers covered by water. Okay, so the formula for the surface area of a sphere. Okay, we can use the current formula sheet here from NESA. This is the 2020 formula sheet. In the section here where it says surface area, it's this one here, A equals 4 pi r squared. Okay, so let's use that. So area is equal to 4 pi multiplied by r squared. So that's going to be 6,400 squared. But we want 71% of that, since that's what we're asked for in the question. The percentage of Earth's surface that's covered by water is 71%. Okay, and let's multiply all of that together and see what we get. So 4 pi, okay, multiplied by 6,400 squared, multiplied by 71%. Okay, and we get a fairly big number. Okay, so that's equal to, I might just write this down, 365 450,163.7. Okay, square kilometers. If we wanted to round that, say, to so many significant figures and use scientific notation to express the answer, in the NESA solution, it's expressed in scientific notation. This is sort of more the exact solution, but if you wanted to round this to, say, 2 significant figures and in scientific notation or in standard form, let's have a look and see how we do this. Let's look at the decimal point. Let's move the decimal point back so that it's between the 3 and the 6. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to write this then as 3.7. So that 6 gets rounded up to a 7, multiplied by 10 to the power of 8, since that's the number of places I've moved the decimal point to get it between the 3 and the 6. Square kilometers. Question 28a. The diagram shows an annulus. Calculate the area of the annulus. So to donut shape, it's the area of the large circle minus the area of the smaller circle. Now, one thing to note is we have the diameter of the larger circle. We need the radius. So r is equal to 5 centimeters, and we can then use that to calculate the area of the shaded part. So that's going to be pi multiplied by large radius, or the larger radius, minus pi multiplied by the smaller radius. So that's from there to there, 3. And that's it. Well, quite straightforward. So pi multiplied by 5 squared minus pi multiplied by 3 squared. And we get 50.265. Okay, it doesn't say to round it, so I'll just leave it to 3 decimal places. Doesn't really matter. Question 1. What is 208.345 correct to 2 significant figures? Now, significant figures means important figures. The most important figure is the 2. The next most important figure is the 0. So, starting with the 2, let's write that down. The next important figure is the 0, but we need to check the digit next to it. If it's 5 or more, the 0 gets rounded up to a 1. Now, all the other digits then turn into zeros. Okay, so 210.000. Anyways, we don't need to write the 0.000. Answer's 210, option B. Question 12. A container is in the shape of a triangular prism which has a capacity of 12 litres. The area of the base is 240 square centimetres. What is the distance, h, between the 2 triangular ends of the container? So first of all, this is a prism, which means volume is equal to the area of the base multiplied by perpendicular height. Now, we know what the volume is. In fact, we're given the volume in the form of capacity. So that's 12 litres. So we need to convert this 12 litres into volume, or units of volume. Now, since the area is in square centimetres, we want the volume in cubic centimetres. So 12 litres is equal to 12,000 millilitres, which is equal to 12,000 cubic centimetres. It's nice to know that 1 milliliter is equal to 1 cubic centimetre. Now let's apply the formula and solve for H. So 12,000 cubic centimetres is equal to the area of the base, okay, this area here, which is 240, multiplied by H. H is equal to 12,000 divided by 240. Okay, and just quickly calculate that. 12,000 divided by 240, and we get 50 centimeters. So, answer D. Question 26a. Calculate the surface area of a sphere with a radius of 5 centimeters, correct to the nearest whole number. So, surface area is equal to 4 pi r squared, which equals to 4 multiplied by pi multiplied by 5 squared. Okay, let's just enter that into the calculator. 4 pi times 5 squared, and we get 314.159, a few more decimals there, which is equal to 314 square centimeters. Question 26d. The field diagram shows a block of land ABCD that has been surveyed. All measurements are in meters. Calculate the length of AB, correct to the nearest meter. So let's identify interval AB. So that's this interval there, and I'm just going to write a pronumeral there next to it. So let's make our calculations a little bit easier. Now, hopefully we could notice that this side AB, or side X, is the hypotenuse of a right angled triangle. So x squared is equal to 32 squared plus 23 plus 10 all squared. So that's the length of the other short side. Okay, so x squared is equal to 32 squared plus 33 squared. Okay. Okay, if you want to evaluate that, 32 squared plus 33 squared. Okay, so that's using Pythagorean theorem, 2,113. Okay. X is equal to the square root of 2,113. Therefore, X equals, and it says to the nearest meter. Okay, square root of 2,013. 45.967, 46 meters. Okay, that's fairly easy enough to round. Question 28e. A company makes large marshmallows. They are in the shape of a cylinder with diameter 5 centimeters and height 3 centimeters as shown in the diagram. Part 1. Find the volume of one of these large marshmallows, correct to 1 decimal place. The first thing we need to note is that we work with the radius, and the radius is 5 divided by 2, r is equal to 2.5 centimeters. Now the volume of a cylinder is given by pi r squared h, based on area times height. So pi multiplied by 2.5 squared multiplied by h, so that's 3 centimeters. Okay, v is equal to, okay, so shift pi times 2.5 squared times 3, and we get 58.90486. So 58.90486 ... and needs to be rounded to 1 decimal place. So that's going to be 58.9 cubic centimeters. So part 2. A cake is to be made by stacking 24 of these large marshmallows and filling the gaps between them with chocolate. The diagrams show the cake and its top view. The shading shows the gaps to be filled with chocolate. What volume of chocolate will be required? Give your answer correct to the nearest whole number. So what I'm going to do is, we need to work out the shaded area. Okay, so what I'm going to do is just draw a rectangle around that and treat this as a composite area. Okay, so
You'll see shortly the reasoning behind this. Okay, so just as long as it's roughly to scale. Yep. Now, the diameter of a circle is 5 centimeters. So we end up with 15 centimeters, like this rectangle is 15 centimeters long and 10 centimeters wide. Okay, so the area of the shaded region is equal to 100. Actually, I'll show all the working out. It's probably better. So 15 multiplied by 10. Okay, so that's this entire rectangle, and we need to subtract out all these circular parts, all these circular components here. Every 2 semicircles obviously makes a full circle. So let's see how many semicircles we have. We've got 1, 2, 3, 4, 5, 6. Okay. So this is pi r squared multiplied by the number of equivalent full circles. So we have 6 semicircles, so that's going to be 3 circles, plus these 2, okay, these 2 full circles, so that makes it 5 full circles, plus a quadrant, or 4 quadrants, 1, 2, 3, 4. So it's actually 6 full circles. Okay. So 15 multiplied by 10 minus pi multiplied by 2.5 squared multiplied by 6, and we get 32.19. Square centimeters, but we want the volume of chocolate, so we're going to fill in these gaps with chocolate. So the volume of chocolate required is equal to 32.19 multiplied by the height of chocolate required. So that's going to be 6 centimeters because each marshmallow is 3 centimeters high. So we're going to multiply that by 6. Okay. And we get 193. So it's just need to round it to the nearest whole number. 193 cubic centimeters of chocolate. Question 30C. A school playground consists of part of a circle with center O and a rectangle as shown in the diagram. The radius OB of the circle is 45 meters. The width BC of the rectangle is 20 meters and angle AOB is 100 degrees. What is the area of the whole playground? Correct to the nearest square meter. So if we look at this shape a little bit more closely, we can see that we have a sector, sort of the major sector here. We have a triangle component, and we also have a rectangular component there. So to find the area of the sector, that's sort of fairly easy. Okay, we can see here that we actually need this angle here. Okay, and that's going to be 260 degrees, since angles at a point add up to 360. The rectangle, in order to find that, we need length DC, which we don't have. Now the triangle AOB, we can use the sine rule for area of a triangle. That's the half AB sine C. So that's easy enough. But in order to answer the question completely, we need length AB, which is equal to length DC, so we can find the area of this rectangular part there. Now, to find AB, there's one of 2 ways we can do this. We can either use the cosine rule, since we have 2 sides, or 2 known sides, and an included angle, and that's fairly easy. Or you could split this triangle down the middle. Because it's an isosceles triangle, when you split the triangle, when you draw a perpendicular, in fact, you can split this triangle into 2 identical right angle triangles, and you could use just basic right angle trigonometry, and that would work as well. So you have 100 degrees, that will be 50 degrees, 50 degrees, this would be 40 degrees there and 40 degrees there. Since also angle sum of a triangle, okay, has to add up to 180 degrees. And being isosceles, these base angles must be equal. So that's the approach that I'm going to take for this solution. So let's work out AB first, since we need that to be able to really unlock this, this entire question, or to answer it completely. So AB, okay, is equal to, now I might just put a sort of a letter X there, and there's another letter X there, okay. So AB is equal to 2 multiplied by, we need the adjacent side here, don't we? So that's going to be X on 45 is equal to cos of 40. So that's going to be 45 cos of 40. 45 cos of 40 will give you X. 2 times 45 cos of 40 degrees will give you 2x. So it will give you this entire length AB. And that's going to be equal to, in fact, I'll write it on the next line here. So 2 multiplied by 45 cos of 40, and we get 68.94399. I might just write the whole answer, and I'll just do all the rounding at the end. 94399, actually 999, 88. Okay, and that's in meters. Now that we have AB, we can now proceed to answer the question. So area of major sector. Okay. So the fraction of the circle that we have is 260 over 360. Okay, so 260 over 360 multiplied by pi r squared. So pi multiplied by the radius, which is 45 meters, and we're going to square that. Okay. 260 over 360 multiplied by pi multiplied by 45 squared, and we get that answer 4594.579256 square meters. Okay. Now area of triangle AOB. Okay. And we have half AB side C, so half multiplied by 45 multiplied by 45. So again, the two known sides and the included angle multiplied by sine of 100 degrees. And we'll just put the answer here since I'm just running out of space. Okay, so half multiplied by 45 multiplied by 45 multiplied by sine of 100, and we get 997 with a decimal component, and that's that. And lastly, triangle ABCD. Sorry, rectangle ABCD. Okay, and that's just length times width. Okay, and we have the length already, which is 68.943, and so on. So 68.9439988 multiplied by the width of this rectangle multiplied by 20. Okay, so 68.9439988 multiplied by 20, and that's the area of the rectangle, so 1378.8799998 square meters. Okay, so it would be a mark for this, a mark for that, a mark for this, a mark for this, and then obviously a mark for the correct answer. So total area okay, is equal to 4594.579256 plus 997.1178,499 plus 1378.879998, and need to answer to the nearest square meter. Okay, so 4594.579256 plus 997.1178,499 plus 1378.879998, and we get 6970.577 dot dot dot. Okay, we need to just round it to the nearest square meter anyway, so I don't have to write the entire decimal. So that's equal to 6971 square meters, correct to the nearest square meter. Question 18. A skip bin is in the shape of a trapezoidal prism with dimensions as shown. What is the volume of the skip bin? So this is a prism, which means the volume is given by the formula V equals area of the cross section multiplied by the height or the depth. So the area of the cross section is a trapezium, and that is found by taking the mean of the parallel sides, so 3.6 and 2.4. So this is this trapezium there. Okay, so it's going to be 3.6 plus 2.4 over 2, multiplied by the perpendicular height of the trapezium, or the face of this, which is the cross section, multiplied by the depth, which is 1.5. Okay, so entering in all of that, let's see what we get. 3.6 plus 2.4. So we're getting the average of the parallel sides, multiplied by 1.2, multiplied by 1.5, and we get 5.4 cubic meters. Option A. Question 21. The length of a netball court is measured to be 30.50 meters, correct to the nearest centimeter. What is the lower limit for the length of the netball court? So in order to answer this question, we need the precision, so the smallest unit of measure. Then we're going to work out the absolute error. So the smallest unit, okay, and it looks like it's measured in 0.01 meters, or in steps of 0.01. That's what nearest centimeter means, in fact. So it's in fact 0.01. That's the second decimal place there. Okay, so I'm going to leave it in meters. So the absolute error is half of that. Half times the smallest unit of measure, or the precision. So if you multiply that together, so half, again, I'm using a calculator because it just, under exam pressure sometimes you can get a mental blank. It's just best just calculate it. 0.005. So you don't want to make a mistake with the decimal places here. So that's equal to 0.005. Now, to get the lower limit for the length of the netball court, we take the measurement here, which is 30.50, minus this absolute error, 0.005, and let's see what we get. So 30.50 minus 0.005, and we get 30.495. So that's going to be option C. Question 22. A concrete water pipe is manufactured in the shape of an annular cylinder. The dimensions are shown in the diagrams. What is the approximate volume of concrete needed to make the water pipe? So this is an example of finding the volume of a composite solid, where we take the volume of the larger cylinder, the outer cylinder, and we subtract the volume of the inner cylinder. Now, there is an algebraic shortcut to this, but let's just work it out by first principles, just something that's easy to understand. So let's work out the volume of the outer cylinder, or the large cylinder. Okay, that's going to be AH, so that's going to be pi r squared h. And the large radius is 0.35 plus 0.1, that's going to be 0.5. 0.45 squared, that's pi r squared, multiplied by 2.8 to get the volume. And we're going to subtract the smaller cylinder. Pi times 0.35 squared multiplied by 2.8. Okay. So let's enter that in and see what we get. Pi multiplied by 0.45 squared multiplied by 2.8 minus pi multiplied by 0.35 squared multiplied by 2.8, and we get 0.7037, and the solution that's closest to that is option C, 0.70 cubic meters. Question 25. In the circle, center O, the area of the quadrant is 100 square centimeters. What is the arc length L correct to 1 decimal place? Now, the way we're going to answer this question is to treat it as if it was a whole circle. That means instead of the area being 100 square centimeters, let's pretend we're talking about the whole circle. So we need to find the radius first. This is what we need to do. Find the radius, and then we can use that to then find the arc length. So let's pretend then that the area is equal to 400 square centimeters. So 400 is equal to pi r squared. Let's solve this for r. So 400 over pi is equal to r squared. Let's take the square root of both sides. So square root of 400 over pi is equal to r. R is equal to, okay, let's enter this in and see what we get. So square root of 400 over pi, and we'll use a few decimal places there. So r is 11.28379. I think 5 decimal places is plenty there. Now let's find the arc length. So arc length, okay, so L is equal to 2 pi r. But we're only talking about 1/4 of the circle, so we're going to multiply that by 1/4. So that's going to be 2 multiplied by pi, multiplied by the radius we just found, which is 11.28379. And then we're going to multiply that by 1/4 because we're dealing with 1/4 of a circle. You could alternatively, you can divide that by 4, it's the same thing. Okay, so let's enter that in and see what we get. 2 pi times 11.28379 multiplied by 1/4, since we're dealing with 1/4 of a circle, and we get 17.724. Okay. 17.724, and the closest answer we have there is option C. Question 30E. A solid is made up of a sphere sitting partially inside a cone. The sphere, center O, has a radius of 4 centimeters and sits 2 centimeters inside the cone. The solid has a total height of 15 centimeters. The solid and its cross-section are shown. What is the volume of the cone correct to the nearest cubic centimeter? So we're only after the shaded region. So here's the cross-section there. Well, first thing we might do is we might write down the volume of the cone. And the cone is a special type of pyramid, which means that it's going to be 1/3 AH, okay, which is equal to 1/3 multiplied by the base area of the cone, which is going to be circular. Okay, so that's going to be pi r squared multiplied by the height of the cone, which is h. So we really need to find two things. We need the r, the radius of the cone, and we also need the h, the height of the cone. So I think we can find the height of the cone easily enough. What we might do is we might just draw a radius here from the center of the sphere O, okay, and it's going to be equal to the radius anywhere else. Okay, that's actually one of the characteristics of a radius or radii, that the distance from O to anywhere on the circumference of the circle is going to be identical. So there's 4 centimeters. Okay, now this one's going to be 2 centimeters here, that's given. So from O to the horizontal dotted line, this one's also going to be 2 centimeters because 2 plus 2 gives us 4, which is also a radius. Now we can work out the height of the cone. So that's an easy mark to get. Okay, so might actually write it as height of cone just to make it a little bit clearer. Okay, rather than just writing h. So height of cone, h, okay, is equal to 15 minus, okay, so that's minus 4 minus 2. Okay, so it's going to be 15 minus 4 minus 2, and that then gives us the remainder. Okay, so I might actually just draw that arrow there so you can see what I'm doing. That's going to be equal to 9 centimeters. Okay, so we have this worked out now. Now we need the radius. Okay, so from this point, okay, so from this point here to this point there. Okay, and notice that we have a right angle triangle. Right angle triangle, we have a hypotenuse, we have one of the short sides, but the other short side is the one that we need, which is the radius of the cone itself. Okay, so this is the r that we need to find. Okay, so the radius of the cone, okay, which is r, okay, is equal to, now, to effect Pythagoras theorem, where we're trying to find one of the shorter sides. So we have the hypotenuse here, which is 4 centimeters, and we subtract the square of the other short side, which is 2 centimeters, all squared obviously. So hypotenuse squared minus 2 squared, so that refers to the hypotenuse in this short side here. Okay. Okay, and that's equal to 16 minus 4, okay, which is equal to square root of 12, or if you've evaluated it directly, okay, so you could have just typed it in directly here, so 4 squared minus 2 squared, and you get 3.4641. I might just write a few decimal places there. Okay, 3.4641011615. It's probably a good idea to maintain accuracy right up until the very end, and then just round it correct to the nearest cubic centimeter. Now that we have the radius of the cone, so we have our r, okay, so volume of the cone is equal to 1/3 multiplied by pi multiplied by r squared. Okay, so that's going to be 3.4641011615 all squared multiplied by the height of the cone, and we've worked that out to be 9 centimeters. Okay, and evaluating all of that. Okay, so 1/3, okay, multiplied by pi, multiplied by, now I can sort of save a bit of time here, that was the previous answer that was on my calculator screen. So we're going to square that, and then multiplied by 9. And we get 113.09733 ... So probably going a little bit beyond there. Okay, and we can just round it to the nearest cubic centimeter anyway, so that's going to be 113 cubic centimeters, correct to the nearest cubic centimeter. Question 13. A rectangular pyramid has base side lengths 3x and 4x. The perpendicular height of the pyramid is 2x. All measurements are in meters. What is the volume of the pyramid in cubic meters? Now the volume of the pyramid is given by the formula. Volume is equal to area of the base multiplied by the height divided by 3. Now the area of the base is 4x times 3x, and the height is 2x, and all of that's being divided by 3. Now to make life a little bit easier, we can cancel that 3 with this 3 there, and we end up with 4x times x times 2x. That's going to be 8x to the power of 3. So it's going to be option A. Question 18. The length of a window is measured as 2.4 meters. Which calculation will give the percentage error for this measurement? In order to calculate the percentage error, we need the absolute error, which is equal to plus or minus half the precision. The precision is the smallest unit that we could measure based on this reading, which is in steps of 0.1 meters. So let's write this down. Precision is equal to 0.1 meters. The absolute error is equal to plus or minus half of 0.1, which is going to be 0.05 meters. The percentage error is equal to the absolute error, which is 0.05, over the original measurement, which is 2.4 meters, and then to convert it into a percentage, we multiply it by 100. So not going to be option C, not going to be option D, can't be option B because we've got to multiply it by 100. The only option we have left is option A. Question 22. A shape consisting of a quadrant and a right-angled triangle is shown. What is the perimeter of this shape correct to 1 decimal place? The first thing we need to do is to find the radius of this quadrant, which is a quarter circle. In order to do so, we need to use the right-angled triangle and we need to use Pythagoras' theorem. So let's call that x. So x is equal to the square root of 10 squared minus 6 squared. Square root of 10 squared minus 6 squared. And we get 8. Okay, so that's going to be, actually we'll put it here, 8. This is also 8. So the arc length of this quadrant is equal to 2 pi r, which is a full circle, but then we need to divide that by 4 or multiply by a quarter to get the arc length for the quadrant. So that's going to be 2 pi times 8 divided by 4, and we get 12.566. Let's add that here, 12.566. Okay, we'll round it later. Now to work out the perimeter, we have 8 plus 6 plus 10 plus 12.566, and we end up with 36.566, which is 36.6. Option B. Question 27C. A shade shelter is to be constructed in the shape of half a cylinder with open ends. The diameter is 3.8 meters and the length is 10 meters. The curved roof is to be made of plastic sheeting. What area of plastic sheeting is required to the nearest square meter? Now, just imagine the shape. Okay, if I was to take this piece of paper and roll it into a half cylinder, okay, you're talking about something that looks like this. Now, if you were to flatten this piece of paper back out, you get a rectangle shape. Okay. Now, the width of this rectangle is in fact equal to half the circumference of this circle. So the area of this rectangle is equal to half the circumference of the circle multiplied by the length. So what's half the circumference of the circle? It's going to be 2 pi r multiplied by the length, which happens to be 10 meters. Now, we're given the diameter of this circle is 3.8 meters. We don't work with the diameter, we work with the radius. Times, now that's going to be 3.8 over 2. So that gives us the radius of the circle, and then we're going to multiply that by the length. Now, let's enter that all in. And we get 59.69 square meters, and then rounded to the nearest square meter, that's going to be 60 square meters. Question 30A. A cylindrical water tank has a radius of 9 meters and a capacity of 1.26 megaliters. What is the height of the water tank? Give your answer in meters, correct to 2 decimal places. Now, the first thing we need to look at is the capacity of the tank. The dimensions of the tank are also important. The dimensions of the tank are in meters, which means that the volume of the tank will be in cubic meters. So we need to think about the relationship between capacity and volume. So the first thing we do is let's convert the megaliters into kiloliters. Okay, and I might just put here that 1 kiloliter is equal to 1 cubic meter, and also that 1 megaliter is equal to 1,000 kiloliters. So let's start our solution off that way. So 1.26 megaliters. To convert megaliters into kiloliters, you're going from a large unit to a small unit. Let's multiply that by 1,000. And that's equal to 1,260 kiloliters, which is also equal to 1,260 cubic meters. That's why kiloliters is such an important unit of measure of capacity, because 1 kiloliter is 1 cubic meter. 1,260 kiloliters is 1,260 cubic meters. Moving on. Volume of a cylinder is equal to area of the base, pi times r squared times height. Now, we know what the volume of this cylinder is. 1,260 cubic meters is equal to pi multiplied by the radius squared. Well, the radius is given here, so I don't have to divide it by 2 or anything. So 9 squared multiplied by the height. Now we can make h the subject of the formula. So 1,260 divided by pi divided by 9 squared is equal to h. And I could do this because everything's just being multiplied together. There's no additions or subtractions. So let's enter this into our calculator and round the answer correctly, and we are done. .95 1487, and rounding it correctly, it's going to be 4.95 meters, correct to 2 decimal places. Question 1. Which of the following shapes has a perimeter of 12 centimeters? Now, perimeter is the distance around the outside of the shape. So if you take, for example, option B, 4 plus 3 is 7, 7 plus 2 is 9, can't be B. You're probably saying, no, it's A. Of course it's A. A rectangle has opposite sides equal. So if that's 2 centimeters there, so this is the height of the rectangle. This one here is 2 centimeters as well. Opposite sides are equal and parallel, of course, in a rectangle. 4 centimeters for the length down here. This one's also 4. 2 plus 4 is 6. 6 plus 2 is 8. 8 plus 4 is 12 centimeters. So the answer is A. Question 8. A person's weight is measured as 79.3 kilograms. What is the absolute error of this measurement? When you talk about absolute error, it's to do with the smallest unit of measure, or the smallest unit that this measurement implies. And the smallest unit is 0.1. Look at the steps. 79.3 kilograms. The next step up is 79.4 kilograms, and so on. So the smallest unit of measure, okay, is equal to 0.1 kilograms, which is equal to 100 grams. And the absolute error is half of this. Okay, so that's going to equal 50 grams. Answer is B. Question 16. A bowl is in the shape of a hemisphere with a diameter of 16 centimeters. Now, first thing is I'm going to write the radius as 8 centimeters because the radius is half the diameter. What is the volume of the bowl correct to the nearest cubic centimeter? Now, the reason why I write the radius is because for most calculations, the radius is in fact more important. Now, a hemisphere is half a sphere. So, volume of hemisphere is equal to 4 over 3 times pi r cubed, but we need to divide it by 2 because it's a half sphere. That's what a hemisphere is. Let's substitute in the radius. Okay, it's important to show all you're working out. Pi times the radius cubed, so that's going to be 8 cubed, and we're going to divide that by 2. So 4 over 3 multiplied by pi multiplied by 8 cubed divided by 2, and we get 1072. And its volume, so it's cubic centimeters. Question 24. Amanda uses 80 kilocalories of energy per kilometer while she is running. She eats a burger that contains 2,180 kilojoules of energy. How many kilometers will she need to run to use up all the energy from the burger? Give your answer correct to one decimal place. 1 kilocalorie is equal to 4.184 kilojoules. So what we're going to do is we're going to convert the 80 kilocalories of energy per kilometer while she was running. We're going to convert the 80 kilocalories into kilojoules. So 80 kilocalories, we're going to multiply that by 4.184. Okay, 80 times 4.184, and we get 334.72. Kilojoules. Okay. Now the burger contains 2,180 kilojoules. We're going to divide that by 334.72 to work out how many kilometers Amanda would need to run. And we get 6.5129. And that's in kilometers, but we need to enter to one decimal place. So that's equal to 6.5 kilometers.
Question 2. What is 0.002073 expressed in standard form with two significant figures? So I'm going to show you two different ways of doing this. Standard form just means scientific notation. So that's times, sort of this number times 10 to the power of something. Let's do it without a calculator first. What we need to do is just move the decimal point a certain number of places, actually move it enough places so that it's in front of the first non-zero number. So that's in front of the 2 here. So what we're going to do is just going to write the number first. So it's good to learn some of these non-calculator strategies. Okay, so we're going to move it 1, 2, 3, so 3 places. And so we're going to write the number with the decimal point now that's been moved, which is now going to be 2.073. Okay, we move the decimal point there, multiplied by 10. Now, because we're making a very small number or a small number into a bigger number, okay, 0.002 is much smaller than 2.073, we need to put a minus sign in front. And the number that you put behind the minus sign corresponds to the number of places you've moved the decimal point. So 1, 2, 3, done. Okay. Now, we haven't quite answered the question. We still need two significant figures. So now we need to round our answer or our number in scientific notation. Two significant figures means starting from the first non-zero digit, which obviously here is the 2. So it's going to be 2.0 or 2.1. So what I like to do is I just like to underline the numbers that I want, the significant numbers, which means they're the important numbers. Okay, so that's going to be 2 point. Now, the 0 either stays as a 0 or becomes a 1 depending on the number behind it. So the number behind is a 7, which means that the 0 must become a 1. We then ignore the 7 and the 3. We don't need to worry about those. Times 10 to the power of negative 3. So that's going to be option D. Okay, so 2.1 times 10 to the negative 3. Now, how could we do this using a calculator? Your calculator can do sort of work in scientific notation and also round to a certain number of significant figures as well. So what we'll do, I'll just move the number there, make sure that number's visible. First of all, mode, actually it's shift setup, and well, it's actually the mode key, but we've got to press shift first. Number 7, or at least on this calculator, it's number 7, SCI, so that means scientific notation. So push that. Now, the next question that it asks you is how many significant figures, that you would like, and then we want 2 significant figures. So press 2. Now type in the number 0.002073, and there's your answer, 2.1 times 10 to the negative 3. So very nice. The one thing that you need to remember to do is to take it back out of that mode. There's 2 ways of doing that. Probably the fail-safe way of doing that is do a factory reset on the calculator. So shift, number 9, clear, all, reset all. So just basically follow the prompts, equals, and we're back out of that SCI mode. Question 5. A plant stem is measured to be 16.0 centimeters, correct to 1 decimal place. What is the percentage error in this measurement? Now, the first thing we need is the precision. Okay, so how precise is this measurement? And that sort of goes by the number of decimal places, or just looking at the measurement there, we can see that the most precise measurement that we could make is in fact the smallest unit, which is 0.1 centimeters. That comes from the fact that it's 1 decimal place. And the next unit up, or the next measurement up from 16.0 is 16.1, then 16.2. So that gives you an indication of how precise the measurement is. Now, the next thing that we need is the absolute error, which is half the precision. So that's going to be half times 0.1 centimeters, which is 0.05 centimeters. Now, the last step, so I'll put this as steps. So step 1, precision. Step 2, absolute error. Step 3 now is the percentage error. Okay, is equal to the absolute error, 0.05, over the measurement itself, which is 16.0, and we multiply that by 100 to turn that into a percentage. So let's do that. Okay, 0.05 over 16.0, multiply that by 100 to turn it into a percentage, and we've got 0.3125%. So 0.3125, option A. Question 25. A composite solid consists of a triangular prism which fits exactly on top of a cube, as shown. Find the surface area of the composite solid. Okay, so I think the operative word here is the word cube, and that implies that we're going to have a lot of sides that are in fact identical. So that's going to save on quite a few calculations there, instead of having to work out one side at a time. Clearly we've got the front, the back, the base, the left and the right sides are identical, okay, in shape and obviously in area. We then have a rectangle up the top and another one on the other side. So we have the left rectangle and the right rectangle. But then we have the triangular face here at the front. We also have the unidentical triangular face at the back. So we've actually got 2 of those, in fact. So planning our solution to get the area of this triangle, because that's really where I guess a good chunk of the work is, we need the height of this triangle. We've got the base of it, that's going to be 8 centimeters, but we need the height. So I'm just going to put a pronumeral x there. Now that's 8 centimeters along the base, so that makes it 4 and 4. Okay, 4 centimeters each side. And we have a hypotenuse here of 5. So by Pythagoras' theorem,
the height of the triangle, okay, x is, okay, you can do it all in one calculation actually, hypotenuse squared, so square root of hypotenuse squared minus the short side squared. Okay, so square root of hypotenuse squared minus the short side squared, and we get 3 centimeters. Okay, now we can proceed to find the surface area of the composite solid. Okay, so I might just put 3 there so we have that height there. Okay, so surface area is equal to, so we've got the front face of the cube, so let's work on the cube first, then we'll work on the triangular prism. Okay, so we've got 8 times 8, and we have 5 of those. Okay, so let's count them one more time, left, right, so 1, 2, 3, 4, that's the back, and 5, the base. Plus, we have the top triangles, so the left and right triangles. Okay, so that's going to be 5 times 8. Okay, so, and we have 2 of those. Okay, plus the 2 triangles. Okay, so that's going to be half the base times the height, half. Now, the base is 8, not 4. Okay, so I know I've got 4 and 4 there. That was just to use Pythagorean theorem, but the base of the triangle, the whole triangle, is in fact 8. Okay, so half the base times the height, okay, 3, and we have 2 of those triangles. Okay, so entering in all of that in the calculator, 8 times 8 times 5, plus 5 times 8, we've got 2 of those, plus half times, okay, I might just put a bracket there for consistency, half times 8 times 3, and there's 2 of those triangles, and we get 424. Square centimeters. Question 27. The shaded region on the diagram represents a garden. The scale is 1 centimeter equals 5 meters. Part A. Use 2 applications of the trapezoidal rule to calculate the approximate area of the garden. So the trapezoidal rule means we're going to try to estimate this irregular area by drawing trapeziums basically around it. And we need 2 applications, which means 2 trapeziums. So the trapeziums have to be equal height. So what we're going to do first is I'm just going to draw it in lightly. Okay, the first trapezium. So this is the first trapezium there. And then we're going to draw in the second trapezium. Now the second trapezium actually doesn't actually look like a trapezium. It looks like a rectangle, in fact. Here we go. So the 2 trapeziums have equal height. Now the scale is 1 centimeter equals 5 meters. So let's confirm this. Okay, so each of these squares is 1 centimeter. Okay, so there's the halfway mark there. So this is of the length of the rectangle. So 5, 10, 15, 20. So the height of the trapezium, or each trapezium, is 20 meters. Now let's work out the side lengths of this trapezium, or the length of the parallel sides. So 1, 2, 3, 4, 5. So that's going to be 25 meters. Okay, 1, 2, 3, 4. So the common side between the 2 trapeziums is 20 meters, and this one's going to be 20 meters as well. Okay. Okay. So now let's apply the trapezoidal rule. So the area of the garden is approximately equal to the area of the first trapezium. So we can see that the trapezium in fact overestimates the area of the garden.
But that doesn't matter. That's going to feed forward into part B. So we'll get to that shortly. Okay, so the first trapezium, okay, it's half the height. So it's half times 20 times the sum of the parallel sides. So that's going to be 25 meters plus 20 meters. So that's the first trapezium plus the second trapezium. Now the second trapezium happens to be a rectangle. So you can either use the trapezoidal rule or the area of a trapezium, or just the area of a rectangle, 20 times 20 meters. But let's just use the trapezoidal rule for consistency here. So half times 20 times the sum of the parallel sides. So it's going to be 20 plus 20. Okay. And entering in all of that. Okay, so we get half times 20 times 25 plus 20. Okay, and I can enter this all as one calculation, or you can work out each trapezium one at a time. Okay, and then just add them together at the end. Plus half times 20 times 20 plus 20. And we get 850 square meters. Now, part B. Should the answer to part A be more than, equal to, or less than the actual area of the garden? Referring to the diagram above, briefly explain your answer. So the answer to part A, we can see that the trapezium overestimates. Okay, so there's some area here that it includes, which is not actually part of the garden itself. Okay, so it'll be more than. Okay. More than the actual area, okay, of the garden. As the shaded area, or the shaded region, is less than the area of the trapeziums drawn in the diagram above. Okay.